Chapter 5 is about probability. The probability is chance. Numeric value representing the chance, likelihood, or possibility a particular event will occur. Okay. Chance, probability. If there are 10 students in my class, then what is chance of getting an A grade? Total is 10 students and 3 students get an A. Then 3 over 10 equals 0.3, 30%. So 30%, the student can get an A grade. That is chance. Or when you look at the weather, then chance of precipitation, 40%, 50%, 90%, like that. That is chance and probability, possibility, likelihood. And the proportion or fraction whose value range between 0 and 1. Like this, 0.3, that is 30%. So, probability is between 0 and 1. 0.1, 0.2, 0.3, 0.3, 0.4, 0.35, something like that. So, up to 1, 100%, 0 is 0%. Some terminology: experiment, outcome, and event. An experiment is process that lead to the occurrence of one and only one of several possible observations. Okay, coin. A coin, head and tail. There are two sides. So tossing and probably head. 0.5, because there are two possible outcomes. So 1 over 2, that is 50%, 0.5. So tossing a coin to get something result, that is experiment. Or observation, you stand on an intersection and then count cars passing. Then let's say passenger cars and something commercial, bus and so on. So count. If you count 100 cars and then 30 among those 100 commercial cars, then 30%, 0.3 is commercial car, chance of commercial car. So to get something, you observe. That is experiment. Tossing a coin, rolling a dice, and so on. That is experiment. An outcome. Outcome is the particular result on experiment. Tossing a coin, head or tail. Possible outcome. There are two, head and tail. And then result with rolling a dice. 1, 2, 3, 4, 5, 6. There are 6 possible outcomes. An event is collection one or more outcomes of an experiment. Okay. Rolling a dice, possible outcome is 6. 1, 2, 3, 4, 5, 6. Among them, I want to get something like an even number. Even number outcome 2, 4, 6. Even number outcome 2, 4, 6. That is event. From outcome, possible outcome, collection. Something collective condition, gives condition, that is event. Types of probability. Classical probability. The probability of success is based on prior knowledge. When I ask you, what is chance of a head when we toss a coin, then you will say it's 50%. Because you know the possible outcome already, only two outcome, head or tail. So if you know total number of possible outcome already, then that is classical probability. Okay. If I ask students tossing a coin 10 times, but that case not always 5-5, not 50-50, not always, sometimes, but 2, 8, 3, 7, 4, 6, something like that. But if we toss a coin like 10,000 times, then it closer to 50%. That is law of large number. Over a large number, tossing a coin like 10,000 times, then that goes to true probability. We know 50-50. Tossing, rolling a dice, it should be 1 out of 6. But rolling a dice 10 times, maybe different numbers. But rolling a dice 10,000 or 100,000 times, then it goes to 1 out of 6, 1 out of 6, 1 out of 6. That is law of large numbers. And empirical probability, we don't know total number of total number of outcome. We should observe or experiment, then we know the possible outcome. That case, empirical probability. Something like the number of successful flight and over divided by a total number of flight. 111 divided by 113. Total outcome depends on observation or experiment. That is empirical probability. And subjective probability, outcome is based on a combination of individuals' experiment. If I ask somebody and the other one do something experiment or observation and then get probability, maybe different results. That is individual different. That case, subjective probability. Mutually exclusive and collectively exhaustive. Mutually exclusive. If we toss a coin only one time, then either head or tail, not both together. So head or tail, mutually exclusive. They cannot come together. If they cannot come together, that is mutually exclusive. Collectively exhaustive. At least one of the events must occur when an experiment is conducted. Okay, tossing a coin, at least one outcome, head or tail. Maybe, what do you think? Stand. Tossing a coin, stand. On the hard surface, never. But like on the beach, sand, tossing a coin maybe stand. But on hard surface, tossing a coin, head or tail. So that case, head or tail, they are collectively exhaustive. Something output we can get that is collectively exhaustive. So if it's hard surface, tossing a coin, head or tail, they are collectively exhaustive, but stand, not collectively exhaustive. Maybe on a beach, that also, standing also collectively exhaustive. Sample space, a simple event and joint event. Simple event described by a single characteristic. Gender, or when we characterize people, then maybe use gender, male or female, using only one characteristic or variable, that is simple event. Joint event is using two or more characteristic or variables. Gender and age. Gender, man and 50 over old and so on like that. So using two or more characteristic and give condition, that is joint event. Okay, probability rules. There are two types of rule: addition and multiplication. Addition, if you see or something or, then is addition rule. If you think it's addition rule, there is or something or, then you determine its addition rule in the probability. Then you should determine if they are mutually exclusive or not. Mutually exclusive or not. So mutually exclusive or not mutually exclusive, then looks like this. Event A and event B, they are mutually exclusive. There is no overlap part. Mutually exclusive means there is no overlap part. Each separate. So if you see or A or B, this one is later, then it will be probability A or B equals probability A plus probability B. Mutually exclusive addition or addition, if it's addition and mutually exclusive, A or B is probably A or B equals P, probably A plus probably B. And if you see or and excuse me, and or, that is addition rule, and then if they are not not mutually exclusive, then A or B is not mutually exclusive means there is some part overlap. So using this formula, probably A or B equals probability A plus probability B, and then subtract minus probability A and B. Subtract overlap part. Okay. If I teach two classes, if one class is prerequisite of the other one, then student cannot take both together, because first one is prerequisite of second one. So without taking first one, student cannot take second one. That case, two classes are mutually exclusive. Then if I teach 10 students and 20 students, first one 10 and second one 20 students, then somebody asks me how many students you teach, then I can say 10 plus 20, because they are mutually exclusive, there is no overlap part. So 30 students I teach, but sometimes if I teach two classes and then they are not mutually exclusive, so certain students take two classes together, if A and B, two classes I teach, then 10 students and 20 students. Among them, 5 students take both together. Then somebody asks me how many students you teach in total. Then, because 5 students from here, 5 students from here, count double. So when I answer how many students I teach, then 10 plus 20 plus overlap double count student minus 5, then 25 students. So something, or there is addition rule, then if they are mutually exclusive or not mutually exclusive, then you should use different formula. If there is overlap part, not mutually exclusive, you should subtract that overlap part, because that part, something like counting double. Example, an automatic sewing machine fills plastic bags with a mixture of beans, broccoli and other vegetables. Most of the bags contain a correct weight, but because of the variation in the size of the beans and other vegetables, a package might be underweight or overweight. Underweight or overweight. Okay. Underweight, satisfactory, overweight. One bag cannot be overweight and satisfactory. Cannot be overweight and underweight. Only one So underweight, satisfactory, overweight, they are mutually exclusive. And then question, what is the probability that a particular package will be either underweight or overweight? Underweight or overweight. So, or, that is addition rule, underweight and overweight, they are mutually exclusive. So, just probably A or C, event A, event C. Underweight is event A, overweight event C. So probability A or C equals probability A plus probability C. Probability A is 100 out of total 4,000. That is 0.025. 100 divided by 4,000 total. And also overweight, probability C, 300 divided by 4,000, that is 0.075. So probability A or C, or underweight or overweight, that is 0.025 plus 0.075 equals 0.1, 10%. That is addition rule and mutually exclusive. The other addition rule. What is the probability that a card chosen at random from a standard deck of cards will be either a king or a hearts? It is a joint event, two or more events together. Okay, king is 1, 2, 3, 4, 5, 6, 7 number characteristic, and hearts, that is shape characteristic. Playing card has 3 characteristics, variables: number, shape, and color. Okay, number and shape together. Anyway, either something, or addition rule, and shape and number can come together. When you take one card, there are 3 characteristics: number, shape, and color. So, number and shape can come together. So they are not mutually exclusive. Addition rule and not mutually exclusive. So probably A or B. A is number king. How many kings in a deck of playing card? There are 4 king. Total is 52. So probably king is 4 out of 52. 4 out of 52 plus hearts. The shape, how many hearts in a deck of playing card? 13 out of 52. So probability of heart is 13 out of 52. And there is overlap part, king and heart. Count double, so we should subtract that part, A and B. King of heart, how many? 1 out of 52. So subtract 1 out of 52. Because this one is not mutually exclusive addition rule. So result is 16 over 52 that is 0.3077. That is 30.77%. This is addition rule, not mutually exclusive. Practice problem number 14 and 20. This one is on blackboard. Let me make this one bigger. Okay, number 14. The chair of the board of directors says there is a 50% chance this company will earn a profit, a 30% chance it will break even, and a 20% will be lose money next quarter. Use an addition rule to find probably the company will not lose money next quarter. There are three events. 50% of earning, let's say event A, that is on profit. 30%, 0.3. Event B, that is break even. 50, that is 50.5 and 0.3. And then 20% of losing money, event C, losing money, 0.2. Okay. This one question, not lose money, that is A or B. So question, we can convert question like probability A or B. Not losing money is either on profit or break even. So probably A or B equals probably A, probability. So probably A is 0.5, 50% plus 0.3, break even. So answer is 0.8, 80%. Addition rule, mutually exclusive, because the company cannot, the result of the business cannot be together, either on profit or break even or losing money. They are mutually exclusive, so just add and then that's it. And next one, use the complement rule. Forget it. Complement rule is if this one, then they are complement rules. So if we use complement rule, probability A or B equals 1 minus probability C, because this one is something, then others are complement probabilities, so that is 1 minus 0.2 equals 0.8. Same result. Number 20. A student is taking two courses, history and math. Probably the student will pass the history course is 60%, and the probability of passing the math course is 70%, 0.7. The probability of passing both is 50%. Passing both. So, from this one, both, taking a history and math courses are not mutually exclusive. This student can take history and math, not mutually exclusive. Then question, what is the probability of passing at least one? At least one means A or B, A or B. A or B, then this one, addition rule from this both, then means not mutually exclusive. So probability A plus probability B plus probability A and B. Addition rule not mutually exclusive. So probability A passing history 0.6 plus passing math 0.7 minus passing both 50% 0.5. So 0.8 80% is the answer. And next one, multiplication probability, addition rule and multiplication rule. Multiplication is joint probability. Something like this. When you see and, if you see or, that is addition rule. But if you see and, that is multiplication rule. And then it will be multiplication rule. Multiplication rule. Then you should determine if they are independent or dependent. Independent or dependent. Independent or dependent. Or dependent. Okay. If I have a deck of playing cards, the total number is, except the joker, 52 cards. If I take one, then whatever results, the probability of that card is 1 out of 52 because total is 52. Then just replace, and then take another one. The probability of that card is 1 out of 52 again, because I replace. So every time is the same because I replace. So first taking card, second taking card, independent. But this case, if I take one card, the probability of that card is 1 out of 52. Without replace, just throw away, take another one. That is 1 out of 51 because first drawing card draw away without replacement. So total card, the number of total card is 51. So taking another one is 1 out of 51. This case, first taking first card and then draw away without replacement, and second one, first one affect second, taking second one. 1 out of 52, but 1 out of 51. So taking first card, first drawing card affects second one. So first and second dependent. So usually replace or not replace. Replacement, not replacement. Replace, independent. No without replacement, that is dependent. Independent and dependent. Two events are A and B are independent if the occurrence of one has no effect on the probability of the occurrence of the others. Replacement, independent. Then probability A and B equals just multiply probability A times probability B. That is independent multiplication rule. Example, a survey of an American Automobile Association, AAA, revealed 60% of its members made airline reservation last year. Members. 2 members are selected at random. Since the number of AAA members is very large, we can assume that reservation 1 and reservation 2 are independent. Then question, what is the probability both made airline reservation last year? Both means A and B. So multiplication, independent, first one's probability is 0.6, second one is 0.62. So reservation 1 and reservation 2 equals, they are independent. So multiply 0.6 times 0.6 equals 0.36. This is multiplication independent rule. Practice number 1, the probability of losing a game of craps, I'm not sure. Dice drawing game played in casinos is 35 out of 100. What is the probability of losing 4 straight games? Something drawing a dice game, and then probably losing is 35 out of 100. That is 0.35. Then question is, what is the probability of losing 4 straight games? First game losing, and the second game losing, and the third game losing, fourth game losing, and then a game drawing a dice, something. Then each game independent. So multiplication and independent. Probability, first one losing and second one losing and third one losing and fourth game multiplication and the game and multiplication and independent. So 0.35 times 0.35 times 0.35 times 0.35 equals something. Do I have answer? Okay. Answer is 0.35 times 0.35 times 0.3 times 0.35 equals 1.5%. Practice problem number 2. A tire manufacturer advertises the median life 50% of our new all-season radial tire is 50,000 miles. If you purchase 4 tires, then what is the probability that all 4 tires will wear out before traveling 50,000 miles? Okay. Tire 1, tire 2, tire 4, 3 and 4 tires. Each tire independent. So 1, 2, 3, 4, they are independent, and then multiplication rule. So answer probability T1 times T2 times and so on, and. Actually, this one is end. 0.5 times 0.5 times 0.5 times 0.5 equals 0.0625, 6.25%. And then conditional probability, that is dependent multiplication problem. A conditional probability is the probability of a particular event occurring given that another event has occurred. That means first one affect second one affect third one, and so on. In dependent, the probability of the event A given that probably event B has occurred is written like this. Actually, probably A given. Okay. So B affect A. We can read this bar, looks like bar, as given. We can read A given B, multiplication and dependent problem. A and B, probably A and B, probably A times probably B given A. Looks something weird, but don't worry about this. A golfer has 12 golf shirts in his closet, something like this. Suppose 9 of these shirts are white and the others blue. 1, 2, 3, 4, 5, 6, 7, 8, 9 white shirts and 1, 2, 3 blue shirts. He gets dressed in the dark, so he just grab a shirt and put it on. He plays golf 2 days in a row and does not do laundry. That means without replacement, without replacement. Without replacement, that is dependent multiplication. The question, what is the likelihood both shirts selected are white? Probability, first one white and second one white. They are dependent because without laundry, without replacement, so equals probability first one white times probability second one white given the first one white. Because first one affects second one. Okay. Initially, there are total 12 shirts. Among them, white shirts are 9. So, probability of white shirts is 9 out of total 12 times 1 is out. So total is 11 without replacement. Total, remaining total is 11. And 1 white is out. So remaining white shirts are 8. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 white shirts. 1, 2, 3 using blue. Blue shirts. So initially there are 9 white shirts and 3 blue shirts. Total is 12. Take 1 that is white. So 9 out of 12 initially, but 1 out. Total 11, and then white 1, 2, 3, 4, 5, 6, 7, 8 remain, so 8 out of 11. Second white given first white is like this. So looks weird, but think logically. how many remain without replacement, how many remaining total, and that one, something like this, then it's not weird, not hard. So answer will be nine out of 12 times 8 out of 11 equals 0.55, 55%. Practice problem 28. There are 3 defective electric toothbrushes were accidentally shipped to a drugstore by clean brush products along with 17 non-defective ones. There are 3 defective and non-defective 17 toothbrushes, 3 defective toothbrushes. What is the probability the first 2 electric toothbrush sold will be returned to drugstore because they are defective? First one sell out, second one